Hello. Today we are going to go over quiz 5. By the way, today I'm a little bit sick, so you can feel from my voice. And please understand, this is the best I can do. So this is why I like online teaching. Even though I'm a little sick, I can do this, and I'd like to finish it quickly and go back home to take some rest. So first question, and again, as usual, the order of the questions can be different in your quiz, and the numbers are maybe different in your quiz too, right? So I'm just giving you an example questions and show you how to do it, and then you can just apply the same methods to your quiz. Then I believe it'll be doable. So first question. An ice cream shop has 9 flavors. One can choose 4 different flavors. What is the total number of possible flavor combinations? Right? So I said 4 different flavors. So technically, like, you can choose like 4 chocolates, 4 vanillas. Like, that is possible, but I am ruling that out. I I have a friend who literally chooses all chocolate. So like whenever he like orders a pint or quart from Baskin-Robbins, like he always chooses one all in on one flavor. But that is not considered here. Anyhow, 4 different flavors are chosen. In that case, you are doing 9 chooses 4. You are calculating 9 chooses 4. And according to the formula, you are calculating this factorial. 9 factorial divided by 4 factorial times 5 factorial. And if you just expand them, like 4 numbers are multiplied in the denominator and numerator, but the starting points are different. Starting numbers follow these, right? This one. And of course, you can do this on calculator or by hand. It is like a lot of numbers must be canceled out. But what I recommend is to use Excel. On Excel, you can use COMBIN because the name of the formula is combination rule. And then you need to enter 2 numbers. If you choose enter COMBIN, you have to enter number and number chosen. In there, we are choosing 4 out of 5, so you have to enter like this, right? Then you get this number. There are 126 different combinations when you choose 4 different flavors, okay? So this is how you can handle it. I recommend you to use Excel. Okay, or maybe like write down all possible combinations on a paper and see if you can make up 126 combinations. Next, there are 5 members of the Avengers: Captain America, Iron Man, Hulk, Thor, and Spider-Man. They got tested for the coronavirus. Suppose that, excuse me, their test results are independent of each other. Probability of an Avenger getting a positive result is 15%. They are also likely to get COVID. What is the probability that Captain America and Iron Man get negative results, but the other Avengers get positive results, right? So here, it is not exactly binomial distribution. What I wanted to show you here is the method you calculate when you know who got negative results and who got positive results. I specified who is positive and who's negative, so it's calculated just based on the special multiplication rule. And I will write 1 for positive result and 0 for negative result. And this is natural in this context because I gave you the probability of positive result. So we are counting positive result, and so usually we think of probability of success. So success is positive result in this context, like given the 15%. It doesn't matter, but anyhow, like 0, 1 is just a way of labeling the two events. Anyhow, what we are calculating is probability that Captain America is negative, and this is intersection, which means and, so different events happen at the same time, and Iron Man is negative, and Hulk is positive, and Thor is positive, and Spider-Man is positive, right? 5 events are happening at the same time, right? And because we assume that they are all independent with each other, um, you can just break down the probability of intersection as a multiplication of each single event, right? So probability of Captain America is negative is 85%. So the first event, Captain America, 85%, multiply 85%, and Iron Man is negative, which is also 85%, so multiply another 85%. And for Hulk, you have to multiply 15% because he is positive. He got positive result, so which happens with 15%. So this must be 15%. And then Thor also got positive result, which is also 15%, multiply 15. And Spider-Man also got positive result, which is another 15%. So in the end, we consider 5 events happening at the same time. So we are going to multiply 5 probabilities for each of them. And but you have to choose the correct probability, the corresponding one to the event that actually happened. So if negative, multiply 85%. If positive, multiply 15%. So calculate that. That is the probability of all these things happen. And again, in here, you don't need to think about combination because I already specified the exact combination who got positive, who got negative results, right? So that is the difference from binomial distribution probability. Okay. Next question. A student majoring in economics is looking for a job. Given his work experience and grades, the probability of getting a job offer from a firm to which he applies is 90%. Oh, great student. If he applies to 3 firms, what is the probability that he gets 2 job offers? Okay, he applies 3 companies and waiting for job offers, and he expects 90% from each firm. It's a binomial distribution because, so you can think it as one application is one experiment, right? When you apply to a firm, its outcome is getting an offer or not. That is a binary experiment, and you expect the probability of success getting an offer is 90%. And you apply to multiple firms, and I should have wrote this down. If you assume that all the firms are independent, all firms, hiring decisions are independent, which is natural. So then you can interpret this as a binomial distribution, right? So I will write the number of job offers he receives as y. Y is the random variable for the job offers among 3 applications. And then we know it is a binomial distribution with parameter 3 and 0.9. So the total number of experiments is 3, and the probability of success is 90% from each experiment. And then we are looking for the probability of 2. Probability y equals to 2. And then you have to think about first the combination, possible number of combinations. When you apply to firm A, B, C, then there are this many number of combinations. Like you could get offers from A and B, or B and C, or A and C. So in the end, like it is simple. That simple. There are 3 possible combinations, which is verified by the combination rule. And then multiply the probability of getting an offer twice, and Failing to get an offer once. You fail once and succeed twice. So multiply each probability there. If you calculate this, you are going to get the answer. So it's just a bunch of multiplications, simple algebra. Okay. Next question. Each NBA team can have 15 players on their roster. So I like watching the NBA, but actually the rule changed recently. A team can have up to 18 players because there are 3 additional called two-way players, who have limited availability, like who cannot play more than like 50 some games. Anyhow, so rule changed, but assume there are 15. They are only allowed to have 15 players on their roster. But but basically the season roster can be 15, but each game they can activate only 13 of them, right? So that means if 3 or more players are injured, the team cannot fill the active roster spots, right? And here we are going to apply the binomial distribution in this context. So each player can get injured with 5% probability, and injuries are independent across players. Okay, then what is the probability that 3 players of 15 on the roster are injured? So we are looking for this number, this probability, and of course you can expect a binomial distribution in this scenario. So each player is an experiment, because a player can have 2 outcomes: injured or not. Injured or okay. And there are 15 players, so there are 15 experiments. And for each experiment, the probability of injury is 5%. So injury is success in this setup, right? So we are going to label injury as success. And then you know the parameters. N is 15, P is 5%, and we are looking for the probability like this. So probability Y equals 3. 3 players are injured out of 15. So then you have to think about the number of combinations. 15 chooses 3. How many players? Who can get injured, or like, you know? So you have to choose 3 out of 15. You have to think about all the possible scenarios, different combinations, and then injury probability happened 3 times, and the probability of not getting injured, 95% happened for the other players, 12 players. So you have to multiply these probabilities. So you can calculate, excuse me, this probability, but it is possible, but it will be very tedious algebra. So I will show you how to do it on Excel. So what you need to do is you are going to use binom.dist, binomial distribution. So binom.dist, and then there are 4 numbers you have to enter. So number S, this is 3 in our example, because we are looking for probability of 3. And out of the number of trials is 15. So out of 15 experiments, what is the probability of 3 successes? Excuse me. And probability of success is 5%. And finally, the final option is cumulative option, whether it is cumulative or not. Right now, we are not using cumulative option. We are choosing false. Then you get this probability. Let me stop this video here. I will continue in the next video.